Hi everyone, and welcome back to our 7-part series of What's New in Generative Design with Solid Edge 2019. For those of you who are following through, welcome back, and for those of you who this is their first video, definitely check out our previous ones. We've gone over a lot of new things, from loads to constraints to the manufacturing settings, and for this video we are going to go over the new displacement constraint. So for those of you who are new, let's briefly go over this part. It's stainless steel. The design space is this entire green region, so the entire part. We have the preserve regions of, I believe, 3.484 inches for all 3 cylinders. So they're preserving those cylinders shapes for us. And the load is 0.5 in the negative, 0.5 in the negative z direction, and same offset value. And the offset value is the amount of material that Solid Edge is saving. Let's undo that for right now. We have a fixed constraint and a pin constraint in blue and in purple. Oh, I actually think we didn't change those colors, although if we wanted to, we can definitely do that. So if we want to change that, change the size or the symbol spacing, just like how we did here, we can do that. So yeah. Oh, I didn't actually change it. Let me go back, press enter, and now it's changed. And the new difference in this particular part that I did mention is our displacement constraint. So this is completely new. Essentially what it means is that the value that we select right here, 0.039 inches, so these surfaces are allowed to move in the normal direction that we decided, which would be the surface. You can also change the direction, but we decided normal to face. So this constraint, or these surfaces, can move in the 0.039 inches into the part until, so they're going to keep it constant until it reaches that value, and topology optimization will take over and will essentially like eat away at the part. But it has the displacement value of 0.039 inches into the feature to keep it, keep the shape essentially. And we have an offset value of, again, 3.484. So you can also change the direction, but it would make sense to keep it into the part because that's where your design space is going to be. You can also do along a vector, coordinate systems, but for us, this part made sense to just do it normal of the surface. So we are expecting to keep these shapes relatively the same. So we shouldn't be seeing any holes in these surfaces. We should be keeping them relatively the same, but only for the green highlighted parts. And here we can see that we could also change the color as we did before, and we can change the sizing of it and the density. All right. So let's see what we get. And this is the 7th topology optimization design. Oh, and it was also run for about 10 minutes and 53 seconds with a mass reduction of 25%. So here we see that our loads are pretty good. There's not a lot of red high stress areas as we seen in the previous previous studies. The blue means they're very low stress, so it's a pretty well made part for these designs, constraints, and loads. But what we really want to pay attention to is the displacement. So we can see, let me toggle through, let's see, the material spreading. Let me press escape. So if we toggle through, we can see that for previous values, or previous shapes, let me go back to this design study. So we were able to see, that there were some holes because we didn't have the displacement constraint. So you can see the big difference if we did toggle through, which we are doing right now. So yeah, you can see the surface is held constant with the displacement constraint, and then all the material was taken out in these regions and these regions, and it's only a 25% mass reduction. So I'm sure that if we increase the, let me press escape again, if we increased the material reduction, that you would probably see more structures, some more mass being eliminated. But it would be interesting, maybe if you in your free time, to play around with the displacement value and the material spreading to see how the structures would be. So as we can see here, there's 25%. And something that I didn't show is that the original mass, it even shows you the original mass with the mass target. So you don't even have to do percentages. You can just type in whatever mass target that you wanted. So say if it was 800, then you could do that as well. But we're just doing it by percentages right now. So yeah, that was the displacement constraint. Definitely play around with that. The next couple videos, we will be moving away from this hinge part, and we'll be moving towards this design block. So we're going to be going over factory safety and some load cases in the next couple videos. So definitely tune in and check out the previous ones. So thanks everyone, and have a good day.